Quadratic linear systems, algebra 2, trigonometry regions. Which values of x are in the solution set for the following system of equations? So you're going to see a little bit of familiar stuff here because you should be seeing things that you saw in Algebra 1. We did quadratic linear systems back then, and that's what we're continuing to do here. So it's really not much new. This is a linear equation. This top equation would be a linear equation. You see that because nothing is squared, and this would be a quadratic equation. We see the x squared in there and so on. And basically, we want to know where do these things cross. Now, you can do this a couple of ways. You can do it graphically since they're both in a y equals format, type them into your calculator and find the coordinates where they cross by looking at the table. There's different traces you can do in the calculator and so on. But what I want to show you today is how to do it algebraically, because sometimes that method may be easier. But we'll explore both methods in class. But for the video, I really want to go through the algebraic approach here. Now, this is a multiple choice question, so we could also pretty much guess and check. Now, they want the x values. So notice that these are not in parentheses. They're not in parentheses because these are not coordinates. These are two x values of separate coordinates. And so what you'll see, like if I were just to draw a sketch here, here's a parabola and here's a line, and notice that it usually crosses twice. Occasionally it'll only cross once, like if it's what we call tangent to it, where if it were just hitting at, like, say the vertex, like right there, it'll only hit once, but typically it's going to cross twice. And so there's going to be two coordinates, and each coordinate is x comma y. And so that's why there's going to be two x value solutions here, and that's what they want. So the way to do this algebraically is to hold on one second for me. I'm just getting a little bit of a delay on my tablet here. Okay, so let's see if maybe if I'm trying to think of a way to speed this up, but it looks like it's okay now. So the key is that these are both set equal to y. And so if they're both equal to y, that means I can set both expressions equal to each other. So if y equals 3x minus 6 and y equals x squared minus 6x, that means I can have them equal to each other. So we'll do x squared minus x minus 6, and we'll set that equal to 3x minus 6. It's almost like substituting, where if y equals 3x minus 6, that means I can replace y with 3x minus 6. And so I can set the expressions equally to each other. And then my next procedure is to set it equal to 0. And so that's going to give us x squared minus 4x equals 0, because what I did was I minused 3x from here and here, and that gave me negative 4x. And then I added 6, and that canceled out there and there. And notice that I moved my stuff to the left, and it's not that it was to the left, I want to move it towards x squared, because I'm going to end up with a factorable term, and so I want to leave x squared where it is and move things toward it. Otherwise, I'm going to have a negative x squared. But sometimes you're going to see things going to the other side. But it's basically I want to create an expression set equal to 0. Then my next step would be to factor. And sometimes it's a trinomial, sometimes it's a dot, sometimes it's a GCF. In this case, it's a greatest common factor problem, where I could take out an x, and that will give me x minus 4 left over, set equal to 0. Set each of these equal to 0, I end up with x equals 0, and x minus 4 equals 0 gives me x equals 4. When solving for x, I would add 4 away from it, so I get 0 and 4. And those are the two x values, so that's the answer. The problem didn't want the coordinates, they just wanted the x values. But if we wanted the coordinates, it's pretty simple. Just plug them into one of the two equations. But the linear equation is going to be much easier to use because there's only one x to substitute into and nothing's being squared. So if I were to plug that in there to y equals 3x minus 6, that would be y equals 3 times 0 is 0 minus 6. I'd get y equals negative 6. And so the coordinate would be 0, negative 6. And for this one, it'd be y equals 3 times 4 is 12 minus 6. y equals positive 6, and so the point would be 4, 6. And so these would actually be the coordinates, the whole coordinates, x comma y. And if I were to type these into my graphing calculator and look at the table, I'd see that they would have these points in common. So let's look at one more example of how to do a quadratic linear system algebraically. And so this one is not multiple choice, and they want it algebraically. That's the key. That's why I'm showing you this, because yes, you could still just type it into your calculator and get it, and that's a great way to check your work, and I'll show you that in class. But for a part 2 on a Regents, they want to see the algebra here. So first thing is they both need to be y equals. I see this one is, but this one is not. So I need to change this to be y equals 2x plus 5. And now it's a y equals problem. And so since y equals x squared plus 2x minus 4 and y equals 2x plus 5, I can set those expressions equal to each other. Bring everything to this side is going to give me x squared minus 9. If I subtract 2x on both sides, it cancels out, and subtract 5 gives me the negative 9, and this is a difference of two squares factorable term. X plus 3x minus 3 equals 0. And so I get x equals negative 3, and I get x equals positive 3 as my x values. But we want this whole solutions here. When they say solve the system, they want x comma y. And so we do need to plug in and find our y value counterparts for these. And I'm just going to use this linear equation I have here. So y equals 2 times negative 3 plus 5. That's negative 6 plus 5 is negative 1. So that would be the point negative 3, negative 1. And then over here, it's y equals 2 times positive 3 plus 5 is 6 plus 5, 11. And so I'm looking at 3, 11. Now, a good idea would be to type this into my calculator and type this into my calculator and see if they do cross here. I could look at the graph, I could look at the table, I could do a trace function, and to verify that that's definitely a way to do. But this is what the work you need to show to do it algebraically. What can make this problem challenging is the factoring step here. It could be AC factoring, it could be a trinomial, it could be, there's a lot of ways that could go. So you have a little bit of factoring practice to do there. And then just substitute to find the missing value. Okay, so we'll practice this tomorrow in class.